Right, this video is going to be consolidation on how to solve trigonometric equations. So, first question here, 1 mark. We need to remember the trig identity sine theta over cos theta equals tan theta. We need to find the value of tan theta. So if we divide both sides by cos theta here, we are going to get 5 sine theta over cos theta equals 2. Then hopefully you know to divide by 5 so that we get sine theta over cos theta, which we know equals tan theta now, and that's going to equal 2 over 5. Now the question is asking just to find the value of tan theta, so we don't need to solve for theta yet. So our final answer is tan theta equals 2 over 5. So for this one we need to solve for tan 2x equals 2 over 5. As you can see the difference between this and that. So first we solve that on our calculator and we get 2x equals 21.8 degrees. That will get you a mark right there. Now that says 2x, so we do need to divide by 2, divide by 2, so one solution is x equals 10.9. Now using our cast diagram, now remember using the cast diagram, tan is positive here and here, and remember we need to use this in our solutions and then solve later. So the next coordinate would be 2x equals 180 plus 21.8. So 2x equals 201.8. We divide that answer by 2, so we get x equals 100.9. That's another solution. Now as you can see, if we go all around this circle and arrive back here to get 360, another solution is 2x equals 360 plus the 21.8 in here, so we get 2x equals 381.8. divide that by 2 and we get another solution for tan as 190.9. That's still in the range between 0 and 360. Now if you was to try this on your calculator, input this figure for x into this formula here, you will get those answers. So 360 add 21.8, that's another one. Now if we continue from 360, we're going to go round, so that's add another 90, so that's 450, and if we go round again you can see that's 540. Now can you see we have to do now 2x to get this bit equals 540 plus 21.8 for 2x equals 561.8. divide those by 2 to get x, and that's going to give us 280.9, and just right at the end x equals 10.9, and all those solutions that you found underline, make your working nice and clear. So have your solutions all nicely written here, so you can get the full mark straight away. And hopefully you can see those are all the values for x between 0 and 360, where tan of these values of 2x will equal 2 over 5. Perfect. So let's look at this old past exam question. Now, we've got to remember the trig identities. Here. Now I'm going to rearrange that to make cos squared theta, because this question is asking us to rearrange it in this form. So if I replace the cos squared theta here with 1 minus sine squared theta, we'll get this equation. Now we need to rearrange that, and we start off by expanding out these brackets, and it's 2 times a minus sign, so that will be 2 minus 2 sine squared theta. Now you can see that if we plus 2 sine squared theta on both sides, we're going to get 2 sine squared, and I'm going to change it to x because that's what the question is asking. X, so this should be x here, excuse that. So let's rearrange that. Equals 3, so you can see what's happening. Now you can see we just need to minus 3 on each side, and we do finish and complete what it is asked. Perfect. Now let's look at this question. We still need to solve, and if it helps, look at this as just set y equals sine x. So this is going to be the same as 2y squared plus 5y minus 3 equals 0. So you would just factorise that as normal, whatever is your preferred method. Now this is it factorised. We need it to equal 0, so what we're going to get is, let's write it over here, 2y minus 1 equals 0, that's what we need to solve, and y plus 3 equals 0. We know y equals sine x, so this will change to 2 sine x here, minus 1 equals 0. Rearrange that to get plus 1 on both sides first. So get 2 sine x equals 1, then sine x equals 1 over 2, and x equals 30. So if you don't remember that off by heart, that's fine, just use your calculator. X equals 30. That is perfect. So we're going to use this solution, and I'm going to go through these answers first, and then we'll hit this one later. So draw your cast diagram. So we can see 30 degrees would be here. This is where sine is positive, because we can see sine x is positive here. So we look at the positive values for sine. If it was negative, then we'll be looking at these two sections where tan and cos are positive, because sine is negative in these two sections between 180 and 360. So that's 30 here. So you can see another solution is quite easily x equals 180 minus 30 equals 150, and you can always double check this by substituting it into your calculator to check that you get a half, and it will be. Those are the two solutions we've found right now. Perfect. Now let's work on this y plus 3 equals 0 now. So we've got y plus 3 equals 0. Now when you get good at this, you don't need to do all this. So we know y equals sine x from before. So we get sine x plus 3 equals 0. Now let's get into good habits. That's minus 3, and sine x equals minus 3. And now we should know we can't inverse sine this to get the x value, because sine x is between the value of -1 and 1. So the only two solutions are x equals 30 and 150, and that will get you the 4 out of 4 marks. Perfect. Now let's look at question 3. They've already given us 1 plus tan theta equals and 5 sine theta minus 2 equals 0. So all we need to solve for is when 1 plus tan theta equals 0 and 5 sine theta minus 2 equals 0 in this range. So step 1, we are going to rearrange the first equation, and I'm going to write it over here. Tan theta equals -1. Let's inverse tan that, and we get -45. Theta equals -45. That has to be a solution because that's in the range. Draw your cast diagram. Now remember, if it's -45, we're going this way backwards from 0, which would make -45, and we say that's 45 degrees. That's perfect. That's one solution there. Now, is the solution, if we go around this way, this would be -180, but tan is positive in this zone, so we do not use this solution. So the next part is, we know we've got a 45 here, so the only other solution here would be 90 plus the 45, or 180 minus 45. You'll get the same answer. So theta also equals 180 minus 45, so theta equals 135. So those are your two solutions for tan here. Excellent. So now we just rearrange this so we can find theta first. We want that range between -180 and 180. So we're going to plus 2 on both sides to get 5 sine theta equals 2. Divide by 5, divide by 5, and then we get sine theta equals 2 over 5. Use your calculator. I'm going to use the fraction button. Press equals. So where can I write this? Theta equals 23.6. So we have 23.6 here, and that's the all positive section, which makes sense because we have the value of sine theta as positive right here, which is 2 over 5. So between 0 and 1, minus 180 and 180, the next point is here. And remember that's 23.6 as well. Remember the symmetry of the graphs. So another solution for theta, which I don't know where to write down now, would be theta equals, and I want to change colour, will equal to 180 minus 23.6. So theta equals 156.4. So those are our two solutions done. Here and here. And that should give you full marks. Now we can check round here if we're going to get a solution of minus 180, but can you see if we go backwards along this way, sine is negative here and sine is negative here, so those are the four solutions. So let's look at the next question now. Now I've rewritten it here so it's nice and clear. Now we've got to remember to use our identities, and that's going to be 3 sine x over cos x, because tan x equals sine x over cos x. Now we want to rearrange this and multiply it out, the cos out, to get 4 sine x cos x equals 3 sine x. Now we want to set this to 0, so we're going to minus 3 sine x from both sides. So what we get here is 4 sine x cos x minus 3 sine x equals 0. And you know, oh, this looks quite difficult to do, but what can we do, like in other questions? We can factorise this and take sine x out. So we take sine x out, then put in 4 cos x minus 3 equals 0. We've got two equations that we can solve. This is when sine x equals 0 and 4 cos x minus 3 equals 0. Let's start with sine x equals 0. So that means x equals 0, and we should know that off by heart, but it's okay, we can use our calculator. So we know 0 is here, and between 0 and 360 the only other place is here, which is the 180 where sine is positive. So the answers for sine x equals 0 is x equals 0 and 180. If you go round the circle, you can see it's not going to work for the other values. So the next section is that we should be working on 4 cos x minus 3 equals 0, but I just want to show you something. Of course, if you go all the way round to 360, sine 360 is 0 as well. But look here, it does say less than 360. That's why you do not include the 360. So part 2, we're solving this. So we plus 3 on both sides, 4 cos x equals 3. Then we divide by 4. So cos x equals 3 over 4. Use our calculators, find out what x is. 41.4. Cos is positive. Let's use our cast diagram again. So I'm going to use this. That's 41.4. We must get a 41.4 here. So this point is actually also the 360 point. Another solution is going to be 360 minus 41.4, which equals 318.6. So that's your 1, 2, 3, 4 solutions for full marks on that question. Nice work. So for this question, we're going to inverse sine 1 over root 2 to find out what x minus 20 is. So we whack that into the calculator. We can see now that x minus 20 equals 45. We solve that, so we plus 20 on each side, and we get x equals 65 as one solution. Now remember, we need to use this 45 when we're using the cast diagram. So we can see another solution is going to be x equals 180 minus 45 which equals 135. But perhaps we shouldn't use x here, we should use, just say, theta, because then we can substitute in x minus 20 equals 135, because we're going to use this from before. So to solve that, we plus 20, so x equals 155, and those are the two solutions. So we just write below x equals 65 and 155, and that's perfect. Now it does say between 360, but I don't think there's any other solutions if you go round. If you do extra solutions, you will lose a mark because there are no extra solutions. So let's look at cos 3x. So we are going to inverse sine this to find out what 3x equals. Now just to save some time on this video, we've got cos 3x equals minus a half, so we inverse cos that to get 3x equals 120. So x is going to equal to 4 when we divide by 3. You can see that here, well, I've drawn this line here, and you can see cos here is negative, so that works perfectly for this. Now can you see, if we add another 120 going round, or do 270 minus 30, that gives us 3x equals 240, so 80 is another solution. Now cos is positive here, so we can ignore that, so we can just start on 360 here. 360, add that 120, so we get 3x equals 360, add 120 equals 480. So we have another solution, x equals 160. Perfect. So here, this is what I mean, we're at 480. Let's add another 120 to 480 to get to this point, which will be 600. So we get 3x equals 600, x equals 200, another solution. Now we go round twice, that's 360, 720, that's going around twice, we get 720. Now add the 120 to get over here, so we get 3x equals 720, add 120, 3x equals 840, so divide by 3, x is going to equal 280. And you can see we've got one final solution, going round, adding another 120 to the 840, 3x equals 120, so 3x equals 960, and x equals 320. So all the solutions are, for x are 40, 80, 160, 200, 280, 320. We don't need to go round anymore, because if we go 3 times round, that's 1080, and that's going to be greater than this value here. And I hope that explains all of that.